Hello everyone, today in this video we'll be discussing the module 4 of TOC super important questions, and in this module we have three topics which are mostly repeated in the single or definitions and theorems. We have pumping lemma and converting CFG to CNF. There are few concepts in this. This is a detailed topic but it comes mostly in both the hours also it has come, okay. And if you want the PDF of this you can DM on Instagram here, and before starting please do like and subscribe. It has been monitors like this. And there is one topic which I have not included, which is GNF, because if you study all these three, GNF is a little bit complex, and I don't have the module wise explanation for that also. That's why I have skipped it. But if you study these three, the more probable one is CFG to CNF. It comes in both the hours, and the definition and pumping lemma are just easier theory ones. Okay, so if you study in this combination, there is a highest chance that you can score more marks here. Okay, so let's get started. The first definition. So these are a few of the questions from the previous year papers, and under definitions and theorems, the questions are as follows. The first question is, what is inherently ambiguous grammar? Okay, a grammar G is ambiguous. Okay, ambiguous means different or doubtful if there exists some string W for which there are two or more distinct derivation trees, as seen in the previous module. If there are two or more trees, that is a ambiguous grammar, right? And if there exists a language which has an ambiguous grammar, that is called as inherently ambiguous language. Okay, so it's just that whatever I have told now. Next, what is CNF and GNF? Okay, the definition you need to write. CNF is the full form is Chomsky normal form. It can be defined as follows. Let G is equal to VTPS. Okay, so the same thing which I have which we have the definition for the CFG, the CNF also have the same definition. VTPS, inside VTPS, all the productions are of the form A goes to BC, which is both non-terminals or a single terminal, and all ABC belongs to the set of non-terminals, and the A belongs to the set of terminal, that is called as CNF. Okay. Next is GNF. GNF is also the same thing, but except that we have an alpha here, which belongs to V star. Okay. The first symbol on the right hand side of the production must be a terminal, and it can be followed by zero or more variables. Okay, so an example is this one. Okay, this is neither in CNF or GNF. Okay, for this you can skip the example, but these definitions you need to write for sure. Okay, next, theorems show that CFL is closed under union, concatenation, star, and complementation. Okay, so this is the theorem. First we will check for the union. Let's assume that there are two languages, L1 and L2, are two CFLs generated by the CFGs G1 and G2. Okay, now assume that V1 or V2 are disjoint, means there is no similarity or same string in both the variables. Okay, there are different, both are different. Okay, that means disjoint means both are different. Now, to consider the to prove that union of two CFLs is a CFL, consider the language L3 generated by the grammar G3, wherein we take the union of V1, V2, and S3. S3 is a start symbol for G3, and T1 and T2, and P3 is the production for G3, and S3 is the start symbol, right? So, if you take it in this way, it is clear from the grammar G3 that G3 is a context free and language generated by this grammar is context free. It's easy to prove that L3 is equal to L1 union L2. Okay, why? Because if there is a string W belonging to L1, then possible derivations from S3 include S3 goes to S1 goes to W. Like that, you can do for S2 also. S3 goes to S2 goes to W. Since both are reaching to W, that means S3 can be S1 or S3 can be S2 also. And all the variables V1 and V2 are present in S1 and S2. So S1 directly we can write as W. S2 also directly we can derive to W. And therefore, we can finally write L1 and union L2 is equal to L3. Okay. Next one is concatenation of two CFLs is a CFL. Okay, here also the same thing you will do. Instead, you'll be writing here S4 is the start symbol and P4 is the production. See, 4 and 3 doesn't matter. You have to write it in this way. Okay, means any different number. Next, after this, what is there is very simple. You just have to write P4 is equal to P1 union P2 union S4 goes to S1 S2. That's it. It is clear from this grammar that G4 is a context-free language, and generated by this grammar is also context-free. So L4 is equal to L1 dot L2. It is closed under concatenation. Okay. Star closure is also same thing. You will have to have write G, then S5 and P5, and after that it is clear from the grammar G5 is context free, and the language generated by this grammar is also context free. Therefore, L5 is equal to L5 star. It is closed under star closure. Complementation is a little bit different. To prove this theorem, consider two L1 and L2 languages, and we know it is closed under union as discussed above. So L1 bar union L2 bar must be context free, since we have assumed CFLs are closed under complementation. Okay, so L1 bar union L2 bar, the whole bar of it must be context free. But according to De Morgan's law, L1 bar L2 union L2 bar, the whole bar is equal to L1 intersection L2. Okay, which must be context free, which is a free of contradiction. So the context free languages are not closed under intersection. Our assumption CFLs are closed under complementation is not true. Therefore, the family of context free languages closed under complementation. Okay, first we will assume it is not closed under complementation, but we will see that intersection is also not closed under under this assumption. So, but we know that intersection is closed under the CFL. So, therefore, the complementation will also be closed under CFL. Okay, that's it. You just have to go through it 2 to 3 times, such that it will be staying in your head. Okay. The next topic is pumping lemma. Okay, for any string, this previous topic also we had discussed, previous module also, the pumping lemma, same thing is here also, except that it is a little bit lengthy one. Okay, for a string z belonging to L, we can write z is equal to UVWXY such that VWX length should be less than or equal to N. The middle portion must not be too long, and Vx is not null, and you should have something in V and X for all I greater than or equal to 0. If you write U, VWX, Y, and V and X, you take the powers as I, it should be present in L. Then only we can say it is context free. But we have to use pumping lemma to show that the language is not context free. That type of question will be asked in exam. Okay. So L is equal to 0 power n, 1 power n, 2 power n, and n is greater than or equal to 1. We have to prove that this is not context free. So let's take n value as 3. Any value you can take. If greater value means easier to distribute the letters. Okay. So n value you can take as 3, and always when you do it, make sure that try as much as your best, make V one character and X also one character, and make both as different characters. Okay, if possible. If not possible, take same also, it doesn't matter. And U and Y can be greater, but VWX should not be greater. So take it single only, that is more better. Okay, so those rules are there. The length of VWX should be less than or equal to N. Since we have taken N as 3, we cannot exceed the length more than 3 here. Okay, that's why it should be very small here. And Vx is not equal to null means the value of this and this, the length is 1 and 1. So 1 into 1 is 1, 1 is not null, and we will be taking the powers of Vi and Xi, X power I. Okay, now if we take V power I means 0 power I will come, because see, we have taken V as 0, right? So 0 power I will come, and here 1 power I will come. So it's raised to I. Okay, and if you pump I value, like if you take 2, pumping means increasing the I value. If you increase the I value, so this is U, this is V, this is W, this is X, this is Y. Now, if you observe how many zeros are there total, 4 zeros. How many ones are there? There are 4 ones and 2, there are 3 twos, right? So it will be 0 power 4, 1 power 4, 2 power 3. But that is in contradiction with the rule which is n, n, n. All these 3 should be n. So when we do the pumping operation, these become different. And this does not belong to L. So whenever something at the end does not belong to L, that means it is not context free. Okay. The same way we have another question. Prove that L is equal to A power j, B power k, C power j, D power k, and j is and k is greater than or equal to 1 is not safe. Okay, it might look hard, but follow the steps. If you follow steps, no question is hard. Okay, so let's take some value. Whenever you have been given some values, take the valid value. Any value I'll take as 3 here. So when you take as 3, what will be forming? Triple A, triple B, triple C, triple D. You'll be writing it here. And V, W, X, you will be taking at most single letters. If possible, just take a different one here. Okay, B and C is here. After that, it's simple. Just raise it to I, V power I, X power I, and pump it. Pump it means whatever is assigned to V and X, double it, or since we have taken 2, we will be doubling it. Okay, so what is the value of V we have taken here? B. So it will become 2B here, and this X will become 2C. Now, after we have done that, since we have increased the value of B and C without increasing A and D, the change will happen here. A is 3, B is 4, C is also 4 actually here. Okay, so see, initially what was C? Initially C was 3, right? See, what was C initially? Initially it was 3, right? So it will become 4. Okay, actually it is 4. Just forgive me for this mistake. You can make it as 4 here. Okay, so A, B, C, and D. So this has changed. It is not JK and JK. It is different. J and K is 3 and 4, but this J and K is 4 and 3. It is becoming different. That means it is not context free. Okay. The last one is prove that the following languages are not context free. Same thing you will do. You will take a string here, UVWXY. Okay, and I is equal to 7 is given. We can take any value. Okay, so this is like A power I, and I is prime. Okay, so what are the rules? take any valid value of I. I is prime means valid value of I will be 2, 3, 5, 7, and so on. So I'll take a greater value, it will be easier to distribute the letters. So I've taken 7 here, so it will be a power 7. I'll take that is belonging to L. Now I will distribute the letters. So 7 A's I will write, and U I will take 2 times here, and V I will take this, W I will take this, X I will take this, and Y I will take this. Okay. Now after this point, what you have to do is, here it is raised to I, right? Here it is raised to I means you will be pumping I value. So I value can make it as 2. That means here it is single A, it will become double A and double A. So total number of A's will become 2, 4, 6, 8, 9, A power 9. But 9 is not a prime number. A power 9 does not belong to L, hence the language is not context free. Okay. Next one is A power n square. N is greater than or equal to 1. If n is 3, if we take the value of n is 3, what will be n square? It will be A power 9. Just write 9 A's here and distribute it. Take V value and X value here. So then pump it. When we pump these values, what will happen? A is here, it will become 4 A's, and this A is here, it will become 2 A's. So totally how many A it has become? 2, 6, 8, 10, 11. A power 11. And A power 11 is nowhere related to n square. 11 is not a perfect square, right? For any value n greater than 1, there is no perfect square in the integers for 11. Okay. So therefore, the language is not context free. Okay. The next topic is CFG to CNF.
Okay, you know CFG from the third module. What a CFG is, context free grammar. We understood how to write context free grammar. It is in this form, right? This is called as context free grammar. Now we have to convert context free grammar into Chomsky normal form, which is CNF. Okay. Now how do we do that? Chomsky normal form has two rules. Okay. Two rules. The CFG, it is only CFG. Okay, it is CFG only, but this CFG has to satisfy two rules. Okay, whatever the productions are there, this is one production, another production, and third production. These productions should satisfy few rules. Okay, what are those rules? First is that S goes to A and B are non-terminals. Okay, the capital letters are non-terminals, means the capital letters are having further derivations, and the small letters are called terminals, and they are ending means they don't have further productions. Okay, these are the ending letters. Okay, that's the difference between the non-terminal and terminal. So whenever we convert a CFG into a CNF, we have to ensure that the production is of the form, either it should have two non-terminals or it should have a single terminal. Okay, these are the only two ways. Another one is there, the starting state which is there, that can have an epsilon also, and rest of the state should not have any epsilon. Okay, so this is the rule which we need to satisfy. Now let's understand how do we do this one. So in exam point of view, the question will be given as a CFG. You will be given with a CFG, and you have to convert it into a CNF. Okay, so there are few rules present. 5 rules are there. Let's understand each rule one by one. The first rule is you have to go in the same order. Okay, if S appears on the right hand side, take S dash goes to S as a new starting state. Okay, so suppose that you have been given a question like this in exam. S goes to ASA or AB, A goes to B or S, B goes to B or epsilon. Okay, now which is the starting state? The starting state is the first one which they give, that is S here. Okay, so S has appeared here also in the right hand side, here also in the right hand side. Whenever S appears in the right hand side, we have to take a new starting state as S dash, which is pointing to S. Okay, so we will be writing it as follows: S dash goes to S, and rest of the thing will be similar. This is same as this one here. Okay, this and this is same, there is no difference, only that we have to take a new starting state. Now the starting state is S dash, previously it was S. Got my point? What's the rule one? Take a new starting state if you find the starting state anywhere in the right hand side. Okay, that's the first rule. Second rule, remove the null productions except if the starting variable has S goes to null. See, I told you that the productions are a Chomsky normal form if the starting state is null. Okay, this is possible. Okay, the starting state can go to null, others can't go to null. So if you find any other production other than starting state which is going to null, like this case B is going to null, C is going to null, and B and C are not starting state, then we have to remove those null productions. How do we remove those null productions? Let's understand it step by step. Okay, for all the questions you need to follow the same rules and same sequence also, first rule, second rule, third rule, then you will be able to solve any question. Okay, so see here, what are the null productions? First, make a set of null productions. Which is the null production here? B goes to null, so I have mentioned here B. C goes to null, so I have mentioned here C. Now, your next step is wherever you find B and C, substitute null there. Means remove that. Okay. Now, let's start from the beginning. In the beginning, can you find a B and C, capital B and C? Yes, a capital C is present here. Now, if I substitute the value of C as null, what will be I getting? What I will be getting? I'll be getting here ABA, right? ABA I'll be getting. Okay. Now, if I substitute B or C as null here, C is over, there is no other letter B here, so I'll be moving to the next one. Here I have both B and C. If I substitute B as null, I'll be remaining with C. If I substitute C as null, I'll be remaining with B. And if I substitute both as null, I'll be remaining with the null only. Got my point? I'll be remaining with the null only. Okay, that's about this one, B and C. Now, is any other B or C present here? No, there are no B or C present. So now, while deriving this one, I have got another null here, right? While deriving, I have got another null here. So I have to include A also as null production. Got my point? Now I have included A as null production. Now, if A is null, I have to again start from the beginning and substitute all the places where A is null. Now see, A and C is null here. Okay, A and C I have to consider again. I had considered C particularly, specifically I had considered C and got this one. Now I have to consider A also. Now, if I consider only A, it will be BAC. If I substitute A as null, it will be BAC, right? BAC. Now, if I substitute C as null, then I got this one. If I substitute both A and C as null, what I will get? I'll get BA. Okay, got my point? That's how we will be writing here. And after we have substituted the value of A as null, then we will be removing the null from here. Okay, and B also we substituted the null wherever we had to, so we'll remove this one as well. And C also we substituted as null, so we'll be removing it. So this is the final equation which you will be getting. Okay, so this is the one which is converted where the null productions are removed. So the rule number 2 is satisfied. Okay, got my point? Just follow the same rule. First, get to know which are going to null, note down there, and wherever you find that letter in any combination possible, you have to make it as null. After that, substitute the value of null in those places and find out what all combinations you can get. In that case, if you get another null in between, like how we got for A, do the same, repeat the same with A also, along with the other null characters combination. Whatever combination you get, keep it. Okay, so this is how you calculate or convert after removing the null productions. Okay, this is the rule number 2. After you have done rule number 2, there are no null productions. Then next you have to check for unit productions. Okay, what do you mean by unit? Unit means 1. Now what do you mean by unit is, see here, S goes to A and B, capital B. Okay, and capital B goes to capital A and small bb. A goes to A and BC and B. Now S goes to B. This is called as a unit production because a non-terminal goes to a non-terminal. It should be a single non-terminal. If two non-terminal means it's fine. If it was like BB, it would have been fine. I would have not have an issue. But if it is only a single B, there is an issue. That is called as unit production. Note down the unit productions here. S goes to B, B goes to A goes to B. These are the unit productions which I have noted down. After you have noted down the unit productions, you have to remove them. Let's have a look how to remove them. So to remove the unit productions, you have to follow a very simple rule. Start from the beginning. Okay, first I'll focus on S goes to B. Okay, S goes to B. If I have to remove, what I will do, I'll just again write the same thing here. Okay, I've written the same thing here, and now what I will be doing is I'll be considering each one by one. What is my first unit production? S goes to B. Now to remove the unit production, instead of B, see, apply your common sense here. The common sense says that if S goes to B and B goes to the following, I can directly write S goes to the following, right? So that's what I will be doing here. S goes to the following, right? I can directly write it like this. Next, after this is done, you have to go for the next one. Okay, here B goes to A. Here S goes to A is there, but I'll come for it again. Okay, so B goes to A and A goes to these following things. Now, if B goes to A and A goes to the following things, I can directly write B goes to the following things and BB here, right? So instead of this A, I can substitute this part here. So that's what I'll be doing. BB I'll be writing here, and this same thing I'll be writing here. This is substituted for A. Now, B goes to B, there is no point. B goes to B, it will go on infinite. So wherever it goes infinite, just remove it. Okay, if it's going to the same letter, just remove it. Now, I've reached this point. Okay. Now, A goes to A, B, C, or B. A goes to B and B goes to the following. So you can directly write A goes to the following here. So I'll write it A, B, C, and B, B. Now you can observe A is repeated, B, C is repeated. I can remove the ones which are repeated. So these two I'll remove it. B, B is remaining. I'll write B, B here and I'll remove from here. Okay, so A and B is done. Now again I will go from the starting and see if I have got any new unit productions. So S goes to A goes to the following, right? So I can directly write here this thing. Okay, so observe carefully. A is present here, no. Okay, so I'll write here A, and BC is present here, no. So I'll write BC, and BB is present, it's present, so I'll not write it again. So this is the final answer which you get after removing the unit productions. Okay, so this is the sequence you'll follow. From the top you'll go and you'll remove all the unit productions, and you'll come back again and check if any unit production is there. You'll keep on doing until you remove all the unit productions. Okay, now moving on to the similar type of example. Here what we are trying to do, let me insert some space here. Okay, so see here also the same thing. Okay, just keep following. What we are going to do, the same rules we'll follow. First, find out the unit productions. The unit production B goes to C, C goes to D, D goes to E. Three unit productions are present here. Now start from the first unit production. B goes to C. Instead of C, I can substitute it as C goes to D, and D I can substitute as D goes to E. E I can substitute as E goes to A. So I can directly write here B goes to A. Right? Eventually it's going to a terminal here. So I can directly write the terminal in this spot here. Right? After that, C goes to D. The next one, this is done. C goes to D. D goes to E. E goes to A. I can directly write here A. D goes to E. E goes to A. I can write here A. Now, after this is done, can you find any other unit production from one non-terminal to a single non-terminal? There is no such unit production present here. So therefore, we have converted or removed the unit productions from the given CFG. Now, after this is removed, you have to check for one next rule. Okay, next rule, what it says, you have to remove the useless productions. Okay, what do you mean by useless? See, S goes to AB, A goes to A, B goes to either B or A. I am nowhere reaching C, D or E from the starting state. Am I able to reach here? No, I'm not able to reach. So these type of things are called useless productions, which we have to remove. How do we remove them? Just erase it from the screen, that's all. Right, you have to just erase it from the screen, then it will be removed. That's how you follow the next rule. Okay, but it's not always as simple as erasing from the screen. You have to follow some other rules also, because it might be having a C in between here also. So we'll be discussing what kind of rules can come in other type of questions. Okay, so moving on to the next rule, which is removal of useless productions. Okay, so see here, this question is given to us, and we have to remove the useless production. Okay, so to remove the useless production, we need to know which production is useless. Okay, so finding out the useless production will go in a reverse way. That is more easier. First we'll find which is the useful production. Okay, how do we know which is a useful production? All the terminals are useful. Okay, listen to me again, all the terminals are useful. So the terminal is A here, terminal is B, all the terminals are useful. So make a set here and write A, B as useful. Okay, after that, A and B, from which letter I am going, which non-terminal I am going through A and going to B, S and A. So S and A also become useful. Got my point? Like that you have to calculate which are the useful symbols and put here. Now after these two, S is useful, A is useful, you have to check if B is useful or not. How do we check if B is useful or not? Now B goes to AB. Now A, B both are coming in this set or not? A is coming in this set, yes. Capital B is coming in this set, no. So we cannot consider this for determining this is useful. C, is C present in this set? No. If it is not present, these both are not present, therefore this is not useful character. This is not useful production. Okay, moving on to the next one. C. AC, is AC present here? A is present but C is not present. B, is B present here? No, it's not. So therefore it is not useful character or useful production. So therefore we will be removing it. We'll be just erasing it from the screen. Okay, so this is then we'll also have to check if B and C are not useful. Wherever either B or C has come, that will also become not useful. Okay, B and C are not useful, right? So wherever B and C, or B or C, either one, if B has come, then this has become not useful. Okay, okay, if B has come, this has not become unuseful. Here A and B, either one, either B or C, if it has come, if it was AC also it was not useful, AB also is not useful, because B has come, then it automatically made A also not useful. Okay, so this also we need to remove. So what we are remaining with, S goes to A, we are remaining with S goes to A here, and BC is removed from here, A goes to B. Now after removing the ones which are useless productions, you have to go for the second thing. The first thing is derivability. Derivability is just what I explained here. Are you able to means get here the useful symbols here or not? Based on that, categorizing it as useful or not, whatever I explained till now, that is called derivability. After that you have to go for reachability. What do you mean by reachability? See, S is the starting state. I'll start from here. Obviously it goes to small a terminal end, that's it. A, I'm not reaching anywhere. A is not present only here. So this is unreachable state, right? Wherever it is unreachable, remove that as well. So once you remove that, you will be remaining with this one, and this is your final answer. After removing the useless production from this CFG, you will be remaining with this production, which is like the one which is not having any useless production. Okay, let's understand this using a second example. Okay, so in this example, useful symbols, terminals are A and B. Any other terminal? No. So A and B are terminals, and A is going from A, capital A, that is also useful symbol. Now we'll be checking each one by one. S goes to A, B. Okay, B I'm not sure, it's not present here. A and C is also not present here. Okay, we'll keep it as like that only. Now we'll see for all of them. Okay, what if after considering B I got this as useful symbol and I write here B, because of writing B this also becomes useful. So we have to check always first. Okay, don't hurry, first you check. Okay, so here A is useful, we need not consider it. Second, B goes to BBA. Is BBA present in this set? Yes, BBA is present. Therefore, this is useful symbol. And if one also I find here as useful, that letter will become useful. So B also became useful here. What about C? C goes to A, B, C, and A. C is present here, no. A, D, B, is D present here, no. So wait for some time. Okay. Again, we will come here. D, B, D. No, D is not present. C is not present. So we'll go back here again. Now S goes to A, B. A, B is present here. Therefore, S is also useful. S is useful. A is useful. B is useful. We'll come back to C. Now, after going through the rotation, coming back again, we couldn't enter C here while we went back here, right? So there is no way how many times I go, I'll not be able to enter C or D here, right? So therefore these two are the useless production. C and D are what? Useless productions. So we will remove C and D from the screen. Now if C and D are useless, the ones which are all having C and D, that all become useless. So A, C becomes useless here, and any other one which are useless here, the no other are useless. Okay, fine. So what will be my final answer? S goes to A, B. Okay, and A goes to A, B, B, A, and A. B goes to A, B, and A, B. Okay, so these are the final states after removing the useless productions. Okay, after that the four steps, you have simplified the grammar which is given in the question. When they give, you have to reach this state after applying the rule 1 to 4. You have to reach this state. This is the simplified CFG. Okay, first step is to get simplified CFG by following the first four rules. The simplified CFG only can be converted to CNF. Okay, simplified CFG can only be converted to CNF. This is the rule. Unless it is simplified, you cannot proceed, you will get the wrong answer. So first follow the rule number 1 to 4, make it simplified, then you are ready to convert it into CNF. Let's have a look at the conversion, how we have to do. Okay, so after applying all the above rules, we obtain a grammar ready to be converted to CNF. Now let's see how do we do the conversion. Okay, so see here, S goes to A goes to AAB, B goes to AC. This is the thing which is given to us. Now we have to convert it into a CNF. What does CNF say? First check if it is already CNF or not. Okay, like that question they won't give, or if it's already CNF, that's a stupidity, but we have to check it always. Okay, so here it will be S goes to ABA. What is the rule? Rule is that the production can be either two non-terminals or one terminal. Okay, so is this two non-terminal? No, it is having two non-terminal, but along with that another terminal is there. This is not the right production. This production AAB, three terminals are there? No, only one I need. And this one non-terminal goes to two non-terminal. This is the only one which is having satisfied the rule. Okay, this has satisfied the rule. Now we have to convert the following into the CNF. Okay, now to convert it into the CNF, the first step you have to do is, see, this stage you will reach after going through all the above steps. Okay, all the above steps which are there, after that you will come here. Okay, first you have to check for all the above rules. Okay, after that only you will come here. Now after you have come here, what you have to do is to convert it into the CNF. The first step is identify the terminals. Okay, what are the terminals here? Terminals are, make a set of terminals A and B. A and B are the terminals. So for each terminal define a production. X goes to A, like that you define for A, and Y goes to B, like that you define for B. Okay, now after defining the X and Y for the following, then you have to substitute the value X with A and Y with B. Wherever you find A, put X. Wherever you find B, put Y. Okay, so A is present here, I'll put it as X, and A is present here, I'll put it as X, and B, wherever it is present, I'll put it as Y. Okay, this was X. So here I have removed all the terminals and I have taken it separately. Now after does it satisfy the CNF, which is having going to two non-terminal? Here it is going to three non-terminal. Here also it's going to three non-terminal. Okay, so we cannot go with that. You have to change it. Okay, you have to make it as two non-terminal. So for that, what I will do is I'll take the first two or the last two, any two you can take, first two or the last two, and make it as another production. Okay, so I'll take AB as W goes to AB, I'll take it as another production here, and I'll take it as WV. Okay, V, any letter you can take. Okay, XX I'll take it here. Now instead of AB I can put W, so here I'll put it as W, and instead of XX I can put it as V. Now it is of the form CNF because S is going to two non-terminal, A is also going to two non-terminal, and the B is going to two non-terminal. Okay, so here we have converted it successfully into the form where it is having the CNF. Okay, let's have a look at a similar type of example so that you understand it more better. So in this example we have been given with this grammar, and we have to convert into CNF. Okay, so CNF rule is either S goes to AB and S goes to A, or any terminal it has to go, or two non-terminals. Okay, so here which all the rules which it satisfies. First, note down the terminals. Okay, which are the terminals present here? The terminals are A, B and C. Now three terminals are present here, A, B and C. Okay, now for each of these terminals define another variable. Now for A I'll define x goes to A, for B I'll define y goes to B, and for C also I can define, but it's already present here, so I need not define it again. If C also had some other things like dx like that and all it had, then I had to define it separately, but since C only has a single variable C here, so I need not define it separately. Okay, so I've defined the first thing, which is the terminals as non-terminal here. Okay, x goes to A, y goes to B. Now wherever I find A and B, I'll substitute with x and y. Okay, so A is present here, I'll put it as x. A is present here, I'll put it as x. A is present here, I'll put it as x. B is present here, I'll put it as y. A is present here, I'll put it as x, and B is present here, I'll put it as y. Okay, so this is okay, B and A is also present here. y, and here also it is y. Now I've converted it in the form of all the non-terminals. Now we have to satisfy this rule. Okay, here in this rule a b should be there, like two non-terminal should be there. This is satisfied, two non-terminal, two non-terminal, three non-terminal are there, we have to change this. Two non-terminal, this is a single non-terminal here. Okay, this also needs to be changed because it cannot be having a single non-terminal. Therefore if it's having a single non-terminal, it's better to keep it as a only. Okay, a and b only. Okay, because again if it's it will reach into the problem of unit production. Again a is going to x and x is going to a, therefore I can directly write a is equal to a. If it is having two letters combined, then only you'll have to substitute. Okay, if it's single, keep it same only. Okay, now after that this I have to change and this I have to change, right? How do we change this and this? Now I can take a and bb as w and v. W as AA I will take, and V as BB I will take. Okay, very simple. Instead of AA I'll write it as W, and instead of BB I'll write it as V. Okay, so this is your final answer, which will be okay, not this one only, the whole thing. Okay, you have to consider the whole thing. This is your converted CNF. Okay, this is in the form of CNF. Okay, for any question, just follow these rules and you'll be getting the answer. Okay. So a question can come like this: remove all the epsilon productions and the unit productions from the grammar. Another can come as useless production also. Okay, this is also a part of the rule. They can ask this also, useless question. So for this question, I'll be solving epsilon production, unit production, as well as useless also. I'll be giving you a hint how do you solve it. Okay, so that if useless also come, you can solve that one also. Okay. So let's start with this question. Okay, the first rule. Okay, what is the first rule? First rule is that whatever the grammar they had given, right? What is the grammar they have given? That grammar you have to write it again here. Okay, and leave some space and write. Okay, because changes are to be made. S goes to capital A and A B B. Okay, and capital A goes to A, and epsilon. B goes to B B, and B B C. C goes to C B. I mean C goes to B only. Okay, is it correct, right? A B B, A epsilon, B B B B C B. Okay, done. This is also from the model paper 2024. Okay, for the 22 scheme. Now S goes to A. Now what you have to do? First, they have asked is remove the epsilon production. Now, what is an epsilon production? In this whole equation, can you find epsilon? Can you find epsilon? Is epsilon present in here? No. Is epsilon present here? Yes, it is present here. Is it present here? No. Is it present here? No. Whenever epsilon is present here, we have to remove it. What do you mean by removing? For removing, we'll be writing here epsilon is nothing but null production. Okay. So in order not to confuse you, let's write epsilon production only. So epsilon production, which letter is forming epsilon production? A. So I'll be writing here A. Is any other letter forming? No, it's not forming. So I'll keep it as A only here. Okay. Now, next thing what you have to do is you have to observe from A, epsilon has come, right? So wherever in this whole equation, wherever you find A, put epsilon one by one. Okay. Now, and epsilon you remove from here. Okay. Put epsilon one by one wherever you find A. Now start from here. Here where you can find capital A. Capital A can be found here. If I put epsilon in this capital A, this will vanish from here. So the remaining one will be only A. I'll be writing only A here. Is capital A present here? No. Is capital A present here? No. Then now capital A goes to this two capital A are there. So I'll do it one by one. If I put epsilon in one of them, it will be AA. If I put on both of them, my answer will be A. Is any other A here? No. Is any other A here? No. And any other letter is there? No. Only A was there. So this is the answer for the first one, epsilon production. Okay. Epsilon production removed. Done. Epsilon production is removed. Now we have to remove the unit production. Okay. Now I'll just copy paste it here. Okay. Okay, I'll just copy paste it here for unit production. Okay, insert some space here. Okay, okay, see here. To remove the unit production, what is a unit production? Unit production is capital to capital. Okay, capital to capital. Okay, that is what is called unit production. Now, to remove the unit production, what you have to do is, okay, unit product. Observe which are having the unit productions. Okay, so which unit productions are present here? In this equation, which unit productions are present? Can you identify and tell me unit productions which are present? Capital to capital. Capital to capital, this is there. Is this unit production? No, it has a small letter also. Terminal is there. Small letter is called as terminal. Capital letter is called as non-terminal. Only single should be there. Then only it will be capital to capital. It is there? No. It is there? No. It is there? Yes. This is capital to capital. I will write the production here. C to B. This is the unit production. How do we remove the unit production? Very simple. What you have to do is to remove the unit production. C to B is the unit production, right? So B, instead of B, I'll be writing this thing. Okay, I'll cut this B and I'll write this thing here. B B B B C. Okay, that's it. This is the removal of unit production. That's it. This is the final answer. Okay. Unit production removed. Got my point. Now there is no more unit production present here, so therefore the unit productions are removed. Okay, BB, BB, C. Okay, that's all about the unit production removed. After this, you have to remove the null productions. In case they ask, sorry, not null, useless production. In case they ask you about the remove the useless production also, we'll have to do that also. Okay, so I'll be telling you how do you do. In case they ask for the same question, remove useless production also. Okay, for useless production, this is just for example. Okay, it's not asked in the question paper. Okay, in case they ask, because they also ask the useless production also, I just took an example of unit and epsilon. Okay, so in this case, what we need to do to remove the useless production, I'll first take the same thing here again. Okay, okay, so these three rules are there, and these three rules also you have to follow in all of the CFG to CNF type of problem. Okay, in all CFG to CNF type of problem, you have to follow these three rules first and then only proceed. Okay, without this, if you proceed, you'll get the wrong answer. Now, what is useless production? Useless productions are the one which useful productions are not there. Okay, what is useless? Which is not useful. Okay, so what is useful we'll write first, and whatever is not useful, automatically it will be useless. Now, see here, useful, all the terminals are useful, small letters. Which all small letters we can see? B is there, A is there, all the small letters are useful. And which letter defines these two, those are also useful. S defines A, right? So S is useful. A defines A is also useful. Okay, B defines, no, only single it should be there. Okay, if double is there, it is not considered. Single A or single B, if it is there, then only it will be considered. Now for B there is nothing. C, there is nothing here. What we have, if there is nothing, means what we have? B and capital B I have. We'll check each of these. Is the small b present here? Yes. Capital B is present here? No. If both of them are present here, I'll be taking this into consideration and taking this as useful. But even if one of them is not there, I'll be taking it as useless. Okay. Before that, I'll check this also. B is there? Yes. B is there? Yes. C is there? C is not there? This is useless production. Okay. If both of them do not qualify for the useful production, I'll be marking the letter which generated that as useless. Okay. Then coming to C, BB, it's not there. BBC, BBC is also not there. Again, C is also useless. Now we have considered B and C as useless. Now, after we have considered B and C as useless, you have to also see which are deriving B and C. That also will be marking it as useless only. Okay. Now B and C are useless, so we will be just removing it from here. Okay. For your information purpose, I'll keep it here only. I'll not remove. But you get the point, right? Now B is useless means wherever you find B, those all become useless. Okay, this became useless, this also became useless, so we'll remove it. And since A and A two times it is there, we'll just keep it as A, and A also does not have B or C here, so that's it. So in final answer, you'll remove this one. Okay, you'll remove this one, and only this one will be the final answer. You got the point. And one more thing you have to check is S goes to A and capital A goes to these things. Now if it was like this, S goes to capital A was not there. Okay, if it was just S goes to capital A, S goes to small a, if it was like this, then I cannot reach A by any chance. I'll start from here, I'll go to A, that's it, end. So this will also become useless because there is no way I can reach A from S. S is a starting set, I cannot reach to A, so that will also become useless. So in that case, I would have written it, but since capital A is there, this is useful only. Okay, so removal of useless protection. Final answer is this one. Okay, in case they asked in the exam. Okay, after this rules, you after the rules, we have to start with the CFG to CNF. Okay, see two back-to-back two questions, same topic. Obtain the following grammar in CNF. Define CNF. Convert the following grammar to CNF. Both of them you have to convert into CNF. Back-to-back 6 plus 8, 14 marks. One topic you learn, 14 marks you'll get from here. And this question, wow, how many marks are there? 6. 14 plus 6, 20 marks. Full on full you can get by just knowing this one concept, CFG to CNF. What's the point? How important and repeated it is. Also on top of that, it's so much repeated. Also in the model paper, it's come. This is from the model 2024 paper. Okay, latest model paper of 22 scheme. Okay, so let's understand how do you solve this question. Okay, the first question we'll be writing here. The first step. Okay, we leave some space at the top. Write it A, S, B, and epsilon. Then A goes to A, S, and small a. Then B goes to S, B, S, A, and BB. Okay, this is the thing which is going to just confirm much ASB, epsilon, AAS, and A, SBS, capital A, BB. Done. Now we'll solve it one by one. Okay, so the first rule. Okay, the first rule, how to convert CFG to CNF. If you want the actual detailed explanation for this, if you don't understand anything here, watch the module 4 video of my TOC video. In that I've explained it with plenty examples along with the steps also. Okay, so here I'll be moving at a bit fast. The first rule is, if the starting symbol is appearing in the starting symbol here only, then we have to take a new starting symbol. That's the rule. Okay, starting symbol appearing here only, we have to take a new starting symbol. S dash goes to S like this. Now starting symbol is this one. Got the point? Okay, this is the first rule. Okay, after this what you have to do, okay, this is the first one. After this what you have to do, the second rule is remove the null productions. Okay, second rule is remove the null production. This is the null production, which is from where it is coming, from S it is coming. So wherever you find S, put as null. Wherever you find S, put as null. Start from here. Here if I put as null, okay, done. There is null here. Next, S here is S. If I put as null, this will be AB. Here if I put as null, I'll be getting as AA. Here if I put as null, I'll get two answers. First null if I put, you'll get as BS. If I put as second as null, I'll get as SB. If I put both as null, I'll get as B. The removal of null production is done here. Okay, the starting symbol can have null. Okay, starting symbol can have null, other should not have null. Okay, that's the rule. Third rule. Third rule is remove the unit production. How do we remove the unit production? Unit means capital to capital. Can you see any capital to capital in this whole thing? Starting set, leave that starting set. And other than starting set, any other have capital to capital? Yes, this has capital to capital, right? So we'll be removing this one. How do we remove the capital to capital? We'll just substitute this whole thing in the place of A. Okay, got the point. The whole thing will be substituted in the place of A. So I'll be doing it in a different way. What I'll be doing is, first this A is there, right? I'll be writing it here, A, and remaining two I'll be writing at the end. It's the same thing only. AS and AA. Now, removal of unit production is also done. Third is removal of useless production. What is useless production? That which is not useful. Which is useful? Useful are the small letters. Small letters are A and B. So A and B are small letters. Who is deriving A and B? A is deriving A, B is also deriving A and B also. So A and B are useful. Now we'll start from here. Leave the starting state here. S, A, S, B. A, S, B. A is present here. B is present here. S is present here. No. Consider the next one. A, B. A, B both are present. So if A, B both are present here, this is useful. This is useful means S also becomes useful. So S also becomes useful. Now since S has become useful, from this S, S dash also become useful. So since S dash also become useful, we have all the symbols present here, all are useful. So there are no useless symbols present in this question. Okay. So useful. Now, after you have followed these three rules, we are ready to convert this question into CNF. Okay. After this, you have to convert it into CNF. Okay, so I'll just copy paste it here and solve this. Okay, done. If you have not liked and subscribed to my channel, please do like and subscribe. It helps me make more videos like this. Okay, so let's continue. Okay, see, this is before the rules. Okay, um, how do I write this? Applying rules. Applying rules of um, null, unit, and useless productions. Okay, so these are the rules which are applied here. Cool. After the rules are applied, ready for CFG to CNF. Now see, for CFG to CNF, the simple rule is present here. All the what is this called? This is called as I'll call it as arrow. All the arrows or the I'm forgetting that word. Okay, I don't know. I'm not remembering what is this called. Okay, all the arrows or the equations which are given here, those should be of the form S goes to S is just for representational purpose. Either it should go to a single terminal or it should go to two non-terminals. Okay, these are the only two rules. Okay, all of them should be of this form. Okay, rules. This is the rule. Either this or this, if it is there, that is valid. Okay, now see, S dash goes to S. Is this valid? No, it's not valid. Why? Because S dash goes to S here, but here we don't have that kind of rule here. Okay, so we'll be solving it one by one. Okay, first step is take A here. Okay, A is going to single A here. That A will be wherever we have here, that will be converting. Okay, so let's start from here. Okay, starting state you will be taking it later. First we'll start from here. Okay, here the first A S B, is it in the state which we are trying to see? Two non-terminal? No, this is having three non-terminal. This is fine, but this is having three non-terminal. So what we need to do is we need to find another state. Suppose that we'll take the state as let's take TU. Let's take U. Okay, you can take any letter. Okay, U goes to AS. I'll be writing. Okay, U goes to AS. I'll be writing, and then instead of AS, I'll be writing it as U. Now see what happened. S goes to UB and AB. Right, S goes to UB and AB. It's of the form this one. Single non-terminal goes to two non-terminal, and single non-terminal goes to two non-terminal. Okay, so this become a valid one. This is also valid one. Here I have three. Okay, I have three, but here a non-terminal is also I mean the terminal is also present here. For this, what we need to do, if we do it in the same way, suppose that V goes to A, and I'll proceed again. So again here it will become a problem. Why? Because again V goes to A, this is neither of this form. So in these cases, what we do is we'll be assigning a letter which is going to a single terminal. Okay, V goes to A, like that we'll be writing. So wherever we find small a along with non-terminal, listen to me carefully. Wherever we find small a along with non-terminals, we'll have to replace it with the non-terminal. Okay, this a will remain as same because it is valid. A goes to small a goes to small a, this is valid one. But wherever it is along with a non-terminal, we'll have to replace it with this non-terminal so that it becomes a valid one. Okay, now again for the B also the same thing we will be doing. Before that, we also need to have a VA separated, right? So we'll be separating VA also, but we'll come to that later. Okay, so B goes to SBS. So B will be I mean UVW. We'll take W for B, and wherever B is there, we'll substitute it as W. Okay, BB BB is it fine? BB BB is also not fine because two non-terminals should not be there. So WW it will become. Okay, and BS is also not fine. It should become W. SB is also becoming W. Single B is fine. A should become as capital V, and this A also should become as capital V. Now after that, which are remaining, which are still not satisfied. VAS is not satisfied. SWS and VAS. So VA I can take it as separate. Okay, UVWX. I'll take X as VA. Okay, so instead of this I can substitute it as x, and this va is already fine, I'll not replace it. Okay, if I substitute this also as x, what will happen? See, this is becoming a wrong one. A goes to x, it is neither of this form, so that's why you should not touch the ones which are already fine. Okay, so here also va, this will become x. Okay, and then sw is there, right? So we'll take x, y as sw. Okay, y as sw, so this will become y. Okay, now I think all of them are in proper form. Just the first one is not in the proper form, but this is fine. Okay, because this is a starting state, that will be remaining like that only. Okay, that's not an issue. Okay, so yeah, I think this is pretty much it, the final answer. Okay, this whole thing is the final answer, and you can get different final answers also. Okay, based on the letters you choose and the way you define. For example, if instead of as I had taken sa as u, I would have got somewhere else as u and b. So the thing is, it should satisfy the condition, these two rules. Till you satisfy the condition, the answer is valid one. Okay, got the point? Okay, so this was about the first one, convert the following grammar into CNF. Okay, second question also is the same one, same rules you have to follow, and we have to do. Okay, so I'll be discussing the second one as well. Try the second one by your own, else you can watch this explanation also, video also. Okay, so let's write the question. Define CNF. Okay, so the definition of CNF I have not given here. I think you can find out from the notes only, the official notes. Okay, define CNF, find in the official VTU notes. Okay, because definition if you don't write, you'll get, means some marks will get cut. Okay, official VTU notes. Okay, okay, you can easily find that and learn from there. It's a simple definition only. Okay, it will just define what is non-terminal, what is terminal, and this transformation is there, that equation, that word is there, that also will be there. Okay, don't forget, define CNF, find in the official notes. I'll be focusing into s goes to 0a and 1b. Okay, s goes to 0a and 1b. Okay, after that what is there? A goes to 0a, 1s and 1. 0a, 1s and 1, that is a, right? A goes to, okay, 0a, 1s and 1. 1bb, 0s, 0, 1bb, 0s, 0. Okay, this is not os, this is 0s, and from here b. Okay, let's confirm first. 0a, 1b, 0a, 1b, 0a, 1s1, 0a, 1s1, bb, 0s, 0, bb, 0s, 0, 1bb. Okay, 1bb, 0, 0. Okay, done. Now this is the thing which is given to us. Here we need to check if it is having the first rule. What is the first rule? Starting symbol is appearing here. No, it's not. So we are good to go. We will not take any other starting symbol. Next, after that, the second rule is epsilon null production. Is there any null production? No. Is there any unit production? Unit production is there? No. Is there any useless production? Useless means which are not useful. So what is useful? Useful is the terminals. What is terminals? Is 1 and 0. 1 and 0 is terminal. From where 1 and 0 came? A, B. A and B both are useful. If A and B both are useful, 1 and 0 is also useful, S is also useful. So all are useful. There are no useless production. You can directly proceed with the question. Now, the rule, which is, what is the rule? The rule is s goes to a, it should be in this form, or s goes to ab, either two non-terminal or one terminal. Okay, one terminal or two non-terminal. Here in this is in the proper form, this is also in the proper form, this is not in the proper form, this is also not in the proper form. Actually, this and this is also not in the proper form because this is a terminal. Okay, I forgot. Okay, so we'll be first defining x for 0 and y for 1. Okay, after we define x and y, we substitute whichever places 0 and 1 is there with x and y. The only places where it is with the non-terminal, not alone. Okay, this one will not replace. This one will become x here, and this will become y here, and this will become y here, and this will become x here. Okay, now which is still not satisfying the rule. Satisfy, 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 satisfy. These two are not satisfying. Okay, so we'll be changing, making a change to this one. We'll take another letter as w, or we'll take it as v. V goes to xa and w goes to yb. Okay, xa and yb will substitute it as va, and yb can substitute as y. Okay, um what was present here previously? YB, right? YB you have to substitute as W. Sorry, okay, W. Now it is in the form of CNF. Okay, this is the same thing, same rules you have to follow. Please do like and subscribe, share this video to your friends, and thank you so much for watching. I'll see you in the next one.